Good morning, good afternoon, good evening. Welcome to Hold On to Your Assets, how to use Fusion 360 Manage to manage your molds. My name is Scott Hoover. I am a solutions consultant for Imaginet Technologies. I've been within the Autodesk channel for a little over 8 years now, implementing the Fusion 360 Manage technology. With me today is David Clifton from BOA Technologies. David, would you please introduce yourself?
I'll be happy to, Scott. I'm David Clifton. I'm the Document Control Manager and the Administrator for Fusion 360 Manage at BOA Technology. I've been a Document Control Manager for 20 years at multiple companies, from electronics to electrical mechanical to purely mechanical products, and I've got experience with multiple PLM software solutions. Feel free to review my speaker bio for more information. And for more information about BOA, visit our website, boafit.com.
Okay, so let's talk about some of the learning objectives that we have for our course today. So we're going to use these learning objectives to kind of dictate the order of topics that we're going to talk about. To begin with, we're going to talk about how BOA set up 2 different workspaces to help manage their assets, and more specifically, their molds. One of those workspaces being a rev controlled workspace, and then the other one being a workflow controlled workspace. Second, we're going to talk about how BOA is utilizing the grid tab within one of their workspaces to keep track of the injection molding shots for each of the molds that they utilize in their production. And then we're going to move into talking about sending out email notifications, and doing this through the use of JavaScripting, and how we have different templates set up for different emails that can send out those emails when we come across any type of data abnormalities within our production runs. And then finally, we're going to talk about how BOA utilized workspace relationships across a couple different workspaces so that they're able to gather data and provide upper management with a snapshot of their mold life expectancy, as well as any other potential issues that could be coming that's evident within the data that we're presenting. So with that, I'm going to pass it over to Dave, and he's going to talk about the workspaces.
Thanks, Scott. One major reason we selected Fusion 360 Manage at BOA was for the flexibility that it provides with an unlimited number of workspaces and the custom JavaScripting that you can use to build functionality not available out of the box or at all with other PLM solutions. BOA's management of molds was particularly troublesome in the beginning, as we had multiple applications. None of them were linked together. Within those, we were trying to manage molds, but it was a complete nightmare. Nothing was ever under control. Nothing was ever up to date. So what we did in Fusion was to create 2 workspaces. And we weren't able to do this until we had gained some experience using Fusion. The first workspace that we built was revision controlled to control the physical, metal, and design properties of the mold. Nothing there can change without an engineering change order using the change order workspace. With this workspace, we control the dimensions of the mold, the type of steel that is used, how many cavities, the physical properties that are driven by engineering drawings and 3D modeling, which in turn is driven by the part specifications and how we want that mold to run in a production line environment. We also use this Rev Control workspace to relate that mold to the part or parts that it builds. More on this later in the presentation. The second workspace, like Scott said, is a basic workspace with workflow. This workflow is where we track the life of that mold from the release of the purchase order to our tooling vendor, through all of the various mechanical and process-related specification testing and rejection states, to ensure that the final product built by that mold meets all drawing specs, leading up to it being qualified for production. It remains there in production until it is no longer capable of building parts to spec, at which time we scrap it. Scott, did you want to show some of those workspaces now?
Absolutely. There you go, Dave.
This is our rev-controlled workspace. We obviously have the identification of the mold and what part that it builds. Section 2 is derived information from the workflow managed workspace, so that if you're in the rev controlled, you can readily just see some basic information that's only available otherwise in the second workspace. And what you happen to see there are the current number of shots that this mold has performed in production, what we anticipate the life of that mold to be, and how much of that life is left. The mold information section is where we record the rev controlled specifics for this mold. What is its size? What are our contract manufacturer's part numbers for the mold and for the parts that it make? What's the class of the mold? What's the complexity? How many cavities are there in the mold? And the material. There's a base steel, a core steel, and a cavity steel. We use these values specifically to set the maintenance interval. When we talk later about the custom email generation, we have JavaScript that once that, in this case, 175,000 shot interval is met, an automatic email is generated notifying our contract manufacturer that it's time to remove this mold from the production line and perform some routine maintenance on it. We'll talk more about the part relationship section later. This is a quick link to the other mold workspace. This is the workflow managed one. And as you can see, if you go to the workflow actions tab, we have quite a sophisticated workflow for our molds. And we'll talk more later about this, but every single one of these states that you see is important for us to establish some statistic measurements and some other data from which we can derive a way to improve the building and the tooling of our molds. The other thing that we do in this workspace, which we call mold shot record, is the grid tab. Once a mold is in the production state, this is where we record the daily product line activity. The measurement we use for this is what we call shot counts. Every day, our product lines overseas delivers to us in a strictly formatted spreadsheet containing the mold, the number of shots that that mold performed that day, the date, and whether any maintenance was performed on a given mold and what type of maintenance that was. A tool built in Fusion that Scott will describe in detail allows us to import this data every day into Fusion for every single mold on our production line. This custom functionality plots this data against our projected lifespan of each mold and how much time of that has been consumed or still available. Scott, you want to give more details?
Absolutely. So let me bring up the presentation. So as Dave alluded to, we utilize the grid tab functionality within the workspace to help keep track of these shots. And as you saw on the screen a moment ago, there's a few different data points that BOA collects, specifically for shots, the date in which the shots were run, as well as the total or the new total for that particular mold. Also, though, on this grid tab, we keep a record of the different maintenances that are required on that mold. And so that is also included as a part of that import that Dave talked about. And we capture within that the type of maintenance that's required for the mold, the date, and then any additional information that is necessary. And this is all important later on when we talk about the reports and the capabilities of being able to report back out on this data. One of the requirements of BOA for this particular helper workspace was the ability for us to import this data daily. As David alluded to, the the contract manufacturers provide on a daily basis the number of shots for every mold that they utilize that day. That number can range anywhere between 10 molds to 25 molds and across a couple different contract manufacturers. So there can be a significant amount of data every day that needed to be entered into the system. And they wanted to eliminate the need for manual entry to one, from a time standpoint, and two, from a mistake standpoint. They didn't want have the ability for a user to potentially fat finger a number as they're typing in these values. So anybody who uses Fusion 360 Manage knows, though, that you cannot import directly into the grid tab. So what we did to overcome this was to build a helper workspace. And this helper workspace is exactly that. It's a new workspace that there are fields within the item details that correspond to every column in that grid tab. And so as a user imports in the data to this helper workspace, a JavaScript was written that then takes that data and transfers it over into the mold and project tracking record. Because they wanted to be able to import this data, we requested from Autodesk that the run scripts on import functionality be turned on. And what this does then is it will automatically run the onCreate script for any record that you import into the system. So when you put it all together, BOA will take that import, load it up into our helper workspace. Every time the new record gets created for each of the line items in the Excel table, it creates that record, runs a script, that data gets transferred over, and then as the last action of that script, it actually will delete the record, thus cleaning that workspace out and always having it such that it imports, sends it, deletes it, and continues on to the next one. So let me demo this for you. For a demo's sake, instead of actually running an import, I'm going to create one manually in our helper workspace, and you will see the script run automatically, and then we'll go back to our mold and project tracking workspace and see the new import that has been added to the grid tab. So I'm going to create a new record. I'm going to put in the mold ID that we're trying to import our shot for. I'm going to put in today's date and our new shot count, 1327581. For shot counts, these are the only three data elements that are required, but you can see here that we do have other data fields for the maintenance information should we need to import a maintenance line item. I'm going to go ahead and save the record. And at this point in the background, the system is running our script, which is taking this data and pushing it over to the grid tab of our mold 2124. You'll notice now that the record has been created, it's automatically been archived. It's automatically been deleted. If I go over to our 2124 and I refresh our page, you will see that we have a new line item put in here for today's date with our shot count that we entered in there, a number ending in 7581 right here. Okay, now we're going to transition into talking about how the creation of these workspaces has allowed BOA to be more efficient with the management of their molds. David?
Yeah, our management of molds at BOA has been revolutionized by the creation of these multiple mold workspaces. It has allowed us to become much more efficient, and we are much more accurate with the recording of the data that used to take forever is almost virtually automatic overnight now. We have used standard features that are out of the box with Fusion, and then of course the customization that we've built with JavaScripting of the tool to accomplish some other things that are not quite so standard. The email notifications via JavaScript is custom. It's built to do multiple things. Scott mentioned one, the shot import error checking, and another one for collaboration notifications that we'll talk about in a while. The shot import error checking, though, occurs every single day and is extremely important. we want to make sure that the mold being reported is actually in production. There have been times when we will get shot counts on a mold that maybe has been scrapped, and it should not be possible for that to happen. Something we will get on the phone immediately and talk to our contract manufacturer about. Usually it's a typographical error, but sometimes it's not. We also want to make sure the mold's not in a repair state or has been removed from the production line for maintenance. Those molds should not be running shot counts on a daily basis. We also want to make sure that the shot count is not less than the shot count of yesterday. The shot counts are given to us by a human person reading an actual odometer that is mechanically affixed to the side of the mold. And every time the mold opens and closes, that mechanical odometer calculates an additional new number. And it's very easy for them to misread that. And so we're making sure there that we're getting an accurate number from them. We also want to make sure that the number of shots over a given 22 or 24-hour period day does not exceed 6,250 shots. It's an easy calculation. We took the fastest mold cycle time, calculated an efficiency rate of about 85%, and a runtime of 22 hours per day because they do take breaks. It's not possible for any of our molds to perform more than 6,250 shots in a given day. So if they do, we think there's another typo in the data that they're giving us. We also want to track as that mold approaches its end of life. We send specific emails to specific people when a mold life hits 25%, hits 10%, and then hits 0%. Our planners are especially interested in this information because based upon that information, they can plan on building a duplicate mold or getting ready to retire a mold, or look at a mold that's at zero life and determine, are the parts that it's making still meeting spec? Is it conceivable that we could extend the life of that mold? It happens many times that the answer to that is yes, and we can extend the life of that mold further. The other thing that we do is that based upon the type of steel and the complexity of the mold and number of cavities, we preset a maintenance interval. For example, 175,000 shots on a given mold. Every time that mold hits that 175,000 shot value, an automatic email is sent out saying it is time to pull that mold off of the production line and perform routine maintenance before you put it back on. We're finding that this routine maintenance is really helping to extend the life of those molds. The other thing that we've been doing now with the workspaces is this interconnectivity. We can go to a given mold and at a glance understand what parts that it makes. If we go to the part in the parts and assemblies workspace, we have a list there of all the molds that make that part and their current state and current life cycle. So that again, at a glance, our engineers, our planners, our contract manufacturer can look at a mold and see if a mold is beginning to approach its end of life. For example, this part 102133, you can see at one time there were 8 molds that make this part. Now, the top 3, 1, 2, and 3, you can see have been obsoleted. So these molds have been scrapped. And you can see that workflow state there at the end of the workflow and current state link. Molds 4, 5, and 6 are production qualified. And you can see that mold 4, well, it's only got 5% of its life left. So we're going to be thinking about time to bring that mold down and to recertify it. Maybe we can bump its life out longer, maybe we can't. But in the meantime, there's another mold, 6, that has just barely been started in production. It's virtually has 99% of its life left. I think they've only run it maybe on one day. And in the mold 7 position, a brand new mold, finished construction, has been qualified. We're probably just waiting for some final measurements to be made on it, but it has yet to be used. And so it's ready to be put on the production line at any time. The last mold, mold 8, you can tell from a glance that it is in mold construction state. It is many weeks out from being ready. So at a glance here, you can see that we've got capacity to build this lace guide, and we're preparing for the future demand, all in one screenshot. Okay. The other better way that we've learned to manage our molds is through reports. The reports function in Fusion is pretty robust, but what we really love about it is the charting capability. And if Scott can pull up one or two of those charts, we're now charting what is the average lifespan remaining of our molds. That's the center chart there. You can see in the far left chart, well, this one, there's a mold there in the middle that is 200% beyond its anticipated lifetime. We know about this mold, and it is one that is still building parts within spec. So we're still allowing it to run. We keep a very close eye on it. The bar across the middle there at 0 is the 0% left state. So most of our molds are above it. We have a few that exceed it. And this allows us to really identify and keep track on those molds. Another chart, mold repairs, is extremely important for us. This one, now that we're getting this data on a daily basis, when a mold is repaired, our contract manufacturer is required to tell us exactly what type of repair that they did. And using this type of data, we can look at the molds that have a high maintenance rate and determine what is it about that mold that is causing it to break so often. What is it in that mold that actually is breaking so often? And we can use this information to design better molds, to eliminate problematical issues that are repeating themselves here, maybe replace them with better technology. This is extremely informative for us and for our tooling vendors to improve the quality of our molds and their lifespan. And each of these repairs in the final chart is the definition of exactly what is the repair type. And we can see here that flash is the most common one. It's just a parting line between where the mold meets. It's a cosmetic issue that we don't want on our finished product. And to eliminate that, there are some simple steps that our manufacturer or our tooling vendor can take to make sure that flash is minimized or non-existent. But the ones like ejector pin, that is a mechanical breakage. Some of these other ones, part sticking, these are things that are of high value to us in learning how to better design our parts, better design the molds that make those parts to eliminate these types of issues. The other thing that we've decided would be helpful is collaboration. Once we got to the point where we are in this discussion managing our molds, we determined there was one final step to take. What we were missing was a single source for collaboration specific to a given mold for a targeted audience. We had used another non-Autodesk solution for that proved to be highly unreliable. And so with the experience that we've gained with Fusion, it was an easy decision to build a collaboration tool right inside the workflow managed mold workspace. In this collaboration section, if Scott can pull it up, we have a predefined list of people, along with a way to add any ad hoc people, depending upon that mold or that project. Any new note that's added using the edit save function on the record automatically sends that note as an email to those listed users. In this manner, back and forth communication between project engineers, tooling vendors, BOA planners, and the contract manufacturers is easy and is captured for posterity there in that note log field. So if you scroll, Scott, you'll see all the collaboration specific to this mold has been captured right here.
Yeah. Now I'd like to step in here for a moment and do a little explanation around these emails that Dave has been talking about, both from the end of life and the data irregular abnormalities from the shot counts, as well as these notes and the note log and collaboration. One of the things that we've implemented was an additional helping workspace to help manage different templates for our emails so that we can control the subject and the message that goes out in that email. As well as then through the use of JavaScripting, as David alluded to here with the notes, who gets that email through the use of fields indicating individuals' names. And so to do that, within another workspace that we refer to as our email templates, we create a record for every email template that we want to send out. The one up on screen represents the mold life at 25%. So when a particular mold on the edit of it in terms of the way, or in terms of the shot counts being added, this script gets executed and will send out an email if it meets certain logical conditions, i.e. it hit the 25% mark. And so within this template, we're holding information in here such as, what ID this is, what record ID it is, as well as the workspace that this applies to, and a description. But more importantly, down here in the subject text or the subject expression field, this is where we indicate what we want our subject of our email to be. The subject expression fields allows us to put some of the JavaScripting syntax, like you see here, item.descriptor, which pulls in the particular record's descriptor and sticks it into the expression of the email. So that shows up as our subject for our email that's being sent. And then within the body, you can type in any type of additional information that you would like, any type of message or what have you. And then in addition to this, you can include workflow comments as well as an advanced print view. In talking about the note collaboration that we were just showing a minute ago, we have created an advanced print view for that field, that in that advanced print view, we include the new note field as well as the historical note field and stick that into the email so that that is visible in that email when you get it. So you can see not only what has been just recently added as a note, but what has been previously added as a note.
Scott, I really like the disable email function in this guy, the second field from the top. Those are all enabled in production tenant, but whenever I clone my production tenant over to my sandbox, I just run a simple import that sets that flag to disable all my emails at one time so that my sandbox, no matter what I'm testing, nobody gets those test emails.
Yep, that's an excellent point, Dave. All right, well now, Dave, I'm going to hand it back over to you to talk about our last topic, the statistics and metric tracking.
Sure. Well, this is a brand new thing that we've just completed in the last month. We determined that there were gaps in our data. There were times when things were occurring that we didn't fully understand, mostly workflow related. Why does a given mold linger in a given workspace state for a length of time? Who's responsible for it staying in that state for what may be too long of a time? Are there other roadblocks? Are there areas of opportunity where we can improve the throughput of our mold manufacturing process? And what we came up with, and the reason for doing so is to measure the performance of our tooling vendors, to measure the performance of BOA project engineers, to see where there are any bottlenecks, who's taking too long to perform their job, and why. So in order to build these KPIs that we now are going to measure the tooling vendor, we're going to measure ourselves, we're going to measure our contract manufacturer against, we built a new workspace. And what we call it in our workflow managed workspace is metrics tracking. And if you remember the workflow that we showed you at the beginning, how it had many states in it. Well, what we've done here is to, in the first column, record how long is a mold in a given state. The second column, we do have workflow loops where if a mold is fails an inspection process during construction, we send it back a state. And once we think that repair has been done, it is resubmitted for re-review. Well, we count the number of iterations that these loops are triggered in the workflow. Lastly, we find when that mold finally is approved in a given state, who approved it and when. And using this information we're finding out that some states are taking longer than they should, some are faster. We're finding we can determine if an engineer is on vacation and he hasn't approved a mold for 5 days when he should have. These last few rows here that you see are summations. They are accumulating overall time in multiple states. This particular mode you can see is currently at what we call a T-phase testing state. And from PO release, it has taken 115 days so far for it to get there. And generally we target about 140 days for a mold to get completely ready and qualified for production. So here we are going to be able to determine where are the slow days, where's the slowdown, where are the bottlenecks, and hold our tooling vendor accountable for molds that surpass the time that we expect them to be able to finish in.
All right. Well, thank you, Dave. So in conclusion for our presentation, I really hope that you guys have gathered some information, some knowledge on how you can utilize Fusion Lifecycle, or excuse me, Fusion 360 Manage to manage your molds and your assets. I mean, most everybody, when they think of a PLM tool, it's simply managing of items and BOMs, managing the change process, and potentially the idea of using assets. But taking some of the stuff that you've learned today, I'm hoping that you'll potentially be able to go out and look at ways that you could manage your own assets using this tool. I'd like to thank Dave for joining us today and allowing BOA to be kind of a case study for this topic. If you have any questions, we're going to open it up now for Q&A.